vertex. The median is going to be the segment that's drawn from the vertex to a midpoint across from it. So median is a segment from the vertex to a midpoint. Okay. Obviously, again, you could have three of them in the triangle because there are three vertices and three midpoints. So if I have a midpoint here, see if this works. It's pretty close. The point what they meet at, it's like we defined a bunch of these other ones. Remember we had perpendicular bisectors, they met at the thing called the circumcenter. Angle bisectors yesterday met at a thing called the incenter. Today, the medians meet at something else. It's called the centroid. The centroid is where the three medians hit. Now, of all the different segments that we deal with, whether they're or the points we deal with, the circumcenter, the incenter, the centroid, and I think we might just talk about what's called an orthocenter. We actually don't do any math with it, it's just a definition. This one is the one that takes a little bit longer to kind of get the idea of how it sets up. What I want you guys to think of here is I'm going to take one of these median segments and draw it outside of the triangle because it's easier to visualize, okay? And I'm going to label it a vertex and a side. I'm going to draw a point. Actually, it's good. Okay, you guys got this under so far?
Yeah,
Okay?
no.
Oh, sorry. I found that if I draw this out separately, it tends to clean up a little bit, if that makes any sense. The three medians intersect. Okay. So the easiest, like I said, the easiest thing to do is to start by saying that one of the endpoints of a median is a vertex, the other endpoint is a side. Are we okay with that? So if I started out, I know that I have the vertex is here, and my side is here. Here was the centroid. Now obviously there's three of them, okay? I'm just drawing it very, very simply. Be a good idea. All right. Now, can I say that the median is the whole thing? The whole thing? No. Well, I'm going to. The whole thing is made up of two smaller segments. It's made up of the segment of vertex to the centroid, and then the centroid to the side. So the whole thing is made up of two smaller segments. And this works for all three of them. Oops. It's made up of those two parts, but there's a special thing that happens. The whole thing is 2/3 the vertex of the centroid and 1/3 of the centroid to the side. Now, you may be sitting there going, oh crap, fractions. Well, it's a lot easier than what you're probably thinking right now. Because how many thirds do you need to make 2/3? Two of them. 3/3 would be the 3/3 would be the whole. So isn't 1/3 half of 2/3?
Yes.
you need 2/3 is made up of 2 singular 1/3s. So if I take 2 1/3, by half of 2/3, or 2/3 is 1/3 each. So basically what happens here is you get a bunch of different ways of writing this out. Example, if this is 6, what's half of it?
3.
What's the whole thing?
9.
That's all it is. The centroid to side is half of the vertex to centroid, or you double it to equal like I said, there's a bunch of different ways to write this out. If we write them all out, it's going to be very easy to manipulate what you're going to use when. Because if you know the centroid to side part's 3, that's the 1/3. If I double it, I get 2/3. So what's double 3? 6. If that centroid to side part was 30, if I double it, what do I get? 60. If this part here was 16, what's the other side? What was it? 8. That's it. If this part is, I don't know, 4, what's the other part? 2. If this part's 12, what's the other one? 24. See how fast this is to work right in 4? Okay, that's all it is. Okay, that's all this is. Now, the way that we use this, so we have medians. They are called the centroid, where they run into each other. And there's a bunch of formulas. We have the whole thing is 2/3, guys. You get that? That's the first one. And then we write out the other ways of doing it. Centroid to side is half the longer segment. If I double it, it equals the other part. And I know there's a lot of words thrown into it, but if you look at how it's going to work out, it's ridiculously fast. Okay? It is very, very easy to work with. So don't get bogged down and freak out that, oh my God, there's a third, I don't know what to do. You've got a button on your calculator, creates a fraction, you hit enter, you multiply it, and it works. Okay? It's very, very easy to work with. Excuse me. There are 2 other ways to write this out, and I'll show you as we get to it, okay? So I want to start with something very easy and just build through. So okay with this so far? So, again, don't write it out. Let's just walk through it. D is the centroid. We okay with that? That's the centroid. 12 is from the vertex to the centroid. What's the centroid to the side? 6. What's the whole thing? 18. Don't freak out about the fractional amounts. It is quite literally, read the question and fill in the blanks. If this chunk is 12, half of it is 6. Yes, sir. Not necessarily. Not necessarily. Sometimes it can be, sometimes it's not. It's more often than not, it isn't. It will be if you have an isosceles triangle or if you have equilateral. That's the only time it really works. not bad, is it? Yes, sir. Okay. Now, I actually have a couple of these already drawn out. I have some of these already drawn out for you guys, so you don't have to keep drawing these up. So let's walk through some examples. And I hole punched them for you so you can put them in your notebooks. Aren't I the nicest guy in the world?
Yes. What? Oh my God, she explained this whole story.
He just said that. Print them after you.
Yeah, because my arms are that long.
If you need longer arms, just hang from the bar and they'll stretch out. You sure? How do you think I got long arms? You're tall. You know how hard it is to get shirts that fit long arms? Well, you understand. I know. And then if you get an extra, because then if you buy an extra large, what happens when you buy an extra large? It's too goofy. That's exactly right. It's tall people problem. You know, it's tall skinny people problem. Yes, sir. What's that? Not yet. Gotta wait till 50. Okay. So let's take a look at how this works, guys. Is this the spare?
Yeah.
Where's this yours?
It was spare for other one.
Now this one here is on the bottom of the front page. Okay? Assuming we're going out of order. We know that we have a centroid, guys. We know we have that centroid, that part there. That is the part that breaks it from the vertex to a median. Since all of these go to a median, that means that all the points T, U, and V are all midpoints. So mark the diagram. Those are midpoints. So here, and you got that. Because a median connects a vertex to a midpoint. Remember, a median goes from a vertex to a midpoint. So that means if I'm drawing from P to V, V is a midpoint. R to U, U is a midpoint, and so on. That's all it is. Okay? So now you've got tick marks around the outside, which means you can fill in all the other missing segments. In doing that, it's easy. If this is 5, this is
5.
another 5, this is
5.
that's a 3, that's a
3.
what's the perimeter?
Got me lost there.
What is perimeter?
The outside.
Distance around the outside. So the distance around the outside is 5, 5, 5, 5, and 3, and 3, otherwise known as 26. That's all it is. You add up the sides. So the big triangle has a perimeter of 26. Now, going on the inside of the triangle, you have the segment from the vertex, from the centroid to side. Centroid to side, is that the 2/3 or the 1/3 segment? Is it the smaller or the bigger segment? It's the smaller one. So it's the 1/3, which means, what do you do to get RS? You double it. So what is it? 4. That's it. Huh? That's fine. It's okay. That's all it is. It is quite literally using the definition, figure out what segment you have, and it's very fast math. Okay? It's very fast. Let's look at the one above it. I believe this was a typo. I think this should say RW is 12. That makes a lot more sense. Okay. Ladies, whenever you have big picture problems and you're given a bunch of questions to ask off of them, never look at the questions first. It'll screw you up. Go directly to the diagram. Know that you've got midpoints. Well, I have one outer segment at 6, which means this is 6. it tells me that from vertex to centroid is 4, which means centroid to side is 2. Do you have all this so far?
Yeah.
It's on there. It's right off of that. Right off the list, knowing what you have. Okay.
No.
Now the other part they give you is the whole thing. They give you the whole thing for TV. I'm going to draw it outside. It tells you the whole thing is 9. If you have the whole thing, we have to figure out, well, how much is the vertex to centroid, and how much is the centroid to side? That's the one we don't have written on here yet. So let's write it out. Vertex to centroid is how much of the whole thing? Is it the longer segment or the shorter segment? It's a longer, so is it going to be 2/3 or 1/3? 2/3. So that means the segment from the vertex to the centroid is 2/3 the whole. And then I can do the exact same thing for the smaller segment. The centroid to side is 1/3 the whole. And yeah, it seems like there's a lot of information to throw into these, but there's only 5 of them. You could have gotten all of that from manipulating the equation from the start, but it's a pain. So why not just walk through and talk about it? What's wrong, Isaiah? You're shaking your head at me.
I don't get it.
Well, remember, the definition of how this works goes way back to the beginning. This segment is created from the vertex to a midpoint. This first part is 2/3 the way. This part is 1/3 the way.
Okay.
That means this chunk is 2/3 the whole thing.
Okay.
That's all it means. If I add these two together, I get a whole. 2/3 and a third is 3/3, otherwise known as 1. Okay? That's where we're getting at. And all I'm doing here is, instead of, just 1 second, Leo. All I'm doing, instead of writing it out in terms of the really nasty book version, is using the words of what you're running into. Because you can see where the vertex is, and you can find the centroid, I forgot what it's called. But if I go through and say, if I label it versus just letters, you're screwed. Why do that? Why not just use it for what's easy vocabulary? All right? All right? So, Leo.
So for like bigger numbers, well, I got 13, I got 6.
Okay?
But for like bigger numbers, we're gonna need a calculator.
Yeah. Basically, for any number, all you have to do is divide it by 3, double it.
Oh, because I just did 2/3.
Times it. It's fine. That works, and that's how you're supposed to do it. Okay? So if you forgot how to work with your calculator in terms of, I got lost on my page here. Where was it? Here it was. If you forgot how to use your calculator to figure out 2/3 of something, this works for anybody's calculator. All you have to do is create the fraction bar. Just create the fraction of 2/3 and hit times 9 or times whatever, and it'll work. Okay. That's all it means, guys. So now if you've got that segment from vertex to the centroid 6, what's the other one? 3. Quick and painless. Okay? So you get 6 for this part and 3 for that part. There's really not much goofiness involved to this at all. It looks a lot worse than it is. Yes, sir? You're about to say so. What? I thought you were about to say something profound. You need a pulling thread? So, you need a thread.
Guys, we've been over
What
this.
part? I'm sorry. Okay, the segment, hey guys, come on. The segment that they're giving us from the median part is the segment TV. TV, they told us is 9. So 2/3 of 9 is 6. Excuse me. And then I cut 6 in half to get the other part. That's what yours is. Plus 6 plus 1 is 9. All right, so let's look at the worst case scenario then. I think that's this stuff, right? No.
Yeah, surf. Oh no.
Oh, I don't have it on here. Forgot that I.
It's okay.
It's okay. We just don't need to do it.
That's funny.
This is actually kind of like making sense to me. Does this get harder?
Algebra.
Well, I mean, this stuff.
Not really.
Okay, cool.
The idea behind it is being able to work through the algebra. And the way that I've been trying to show you guys how this stuff works itself through was by using what points are you running into? What points are you setting yourself up with? So as you flip over to the other side, you'll see that you've got these 3 algebra problems. Now, as you start to read through that, you've got 3 problems dealing with the same diagram. What I'm going to do is deal with them one at a time. So that way we don't get all bogged down by trying to fill in the blanks into the diagram, because it's not worth it. It's too messy. So I do a couple of different things. Remember how in the very beginning I redrew just the median itself, labeled it? That's the easiest way to do these types of problems. Redraw the segment that you're working with, and then figure out what part is the vertex to the centroid, what part's the centroid aside, and what's the whole thing. So if I'm looking at the diagram, it tells me that G is the centroid. So that's where all the medians run into each other. The first problem is talking about the segment CG and CE. So what I'm going to do is just redraw that portion of the problem out. So it's C, G. I'm just going to redraw that part out of it. Which means this was the vertex. So here's my vertex, centroid, and side. So that means CG is vertex to centroid. Oops. And CE is the whole thing.
That's all it is.
So now you have 5 things to look at. Which one of the 5 formulas we've written out deal with just vertex to centroid and the whole thing? Top one over there. Everybody see that? So when I'm going back and forth with my notes on this stuff, I'm looking to see which one am I going to use. Well, the only one that deals with just those 2 is this formula. So I write it down. I know that the vertex to the centroid is 2/3 the whole. Well, according to the problem, 3x plus 7 is 2/3. What was the whole thing? 6x. So what's 2/3 of 6? 4. Very good. Okay. It depends on what you're working with. That's the point. You have to identify what are you working with, because I wouldn't take 2/3 if I'm just working with the centroid side part. I have to make sure I'm using which part to work with. See what I'm saying? You gotta make sure you work with the right part. So 2/3 of 6 is 4x. What's x equal? 7. Subtract 3x and you're done. There you go. It's that quick. Once you fill in the blanks, it's that fast. That's the idea. Label very specifically, and it works out so much faster. Okay? That's the idea. Okay? That's the idea. Let's try the next one. Waiting.
Oh, so do we just put it in rice? That's what you're saying?
I just said solve for x.
Oh, okay.
If you substitute back in, then you should get 2/3, 1/3. You should have one side that's double the other.
Okay.
Okay.
Have you ever been called out on your Murphyisms?
For what?
Like, that's the idea, or it's just that.
Yes. Yes, I have. Many times.
I just think it's funny.
You go to the next part. What's that?
Like,
Never mind.
No, I just put it in the next page because I'm just saying space. I'm just trying to show. I'm just going to reuse. I'm just reusing diagrams, really. Okay. The next one's dealing with FG and AF. That's this segment.
So we use a 1/3.
I don't know yet. I haven't written it out. So here's side, centroid, and vertex. Everybody okay with labeling it like this?
Yeah, it's easy.
It's extremely specific work by doing it this way. It just forces you to slow down and fill in the blanks. Okay? So we are dealing with FG is the centroid to side, and AF is the whole. So then I go back and look at the different ways of setting this up. Which one am I going to use?
1/3.
Yep. Centroid to side is 1/3 the whole thing. Write it out. Fill in the blanks. Centroid to side is 1/3 the whole. I forgot what it was. X plus 8 is 1/3. Was it 9x minus 6?
Yeah.
And honestly, this is about the only spot that you guys will probably make a mistake, is you'll forget to distribute to both terms in the parentheses. Draw your arrows when you do it. When you draw your arrows, it makes you kind of double check yourself. Okay. Is it okay if I slide this up a little bit?
Yeah.
Angel, stop clicking.
What?
Stop clicking.
Oh, stop talking. 1/3 of 9 is what? 1/3 of 6 is? So we have x plus 6 is 3x minus 2. Move stuff around rather real quick, and you're going to get 8.
Yeah, it's actually
Yeah.
safe.
Was it-
Very supposed to
Was this side x plus 8?
be. Yeah.
Oh, sorry about that.
That's okay, that's for Murphy.
So you get 10 is 2x, which means x is? Like I said, it looks a lot worse than it really is. It's a matter of just filling in the blanks for what you know. Okay? Quick, put your finger on her nose like this. Works in the cartoons.
Or look at the light.
Yeah, you look up by the way.
No, if I look at the light, it makes me sneeze. Yeah.
Yeah.
Oh,
Stop.
Or the sun.
That actually works. I like seeing
about to sneeze.
No, I wouldn't be doing it.
Last one.
Shut up.
Last one. The last one is the one you have, in this one, or in this example, you're dealing with both internal segments. You're not dealing with the whole part. You have B, G, D, vertex, centroid, side.
I just this last one. Yes.
We have BG, which is vertex to centroid. DG is the centroid to side. Which means you gotta take a couple of seconds to figure out which of them are you gonna use. Since you only have those two, I can't work with the whole part. I can say the centroid to side is half vertex to centroid, or I can say that if I double one of the sides, it equals the other. This is the easier one to work with because you don't have to deal with that. Okay? So I write it out. I double my centroid to side, then it will equal the other part. Okay? I'm not writing this in terms of any variables or anything like that whatsoever. All I'm doing is I'm using the actual terminology in the diagram because it's the same thing every time. Why make it harder on ourselves to do any of this? Okay? Why make it any harder? So let's see. What's BG? So that is, oh, sorry. Centroid to side is the DG. Excuse me. So it's 5x or 4x minus 5. So if I double that, it has to equal so if you double 4x minus 5, what do you get? 8x minus 10. So you have 8x minus 10 is 5x minus 1. You're back to a very fast two-step equation. Variables on both sides. Pick on the little guy. We're going to move the 5x to the left, and we'll add 10 to the right. The whole idea with this stuff, guys, really is to know which part you're working with. If you understand and see which part you're working with, it's plug and chug. Okay? Yes, sir?
So do you add one?
What do you mean?
Yes. 3x equals 9.
Oh, no, what I did here is, from here, I added the 10x, or 10 over, and I subtracted 5.
I'll start with you when you were done.
I did them both at the same time. I said it out loud, I didn't write it. I do that a lot, because I run out of ink. It's expensive. You know how much printer ink is?
No,
A lot.
It's more than like oil. It's more than gold.
Not more than gold.
It's not. It's up there. Maybe like silver. It costs as much as silver.
Okay.
More than oil. That's where the real treasure is. Printer ink.
Yeah.
Fuel of the 22nd century.
Do you remember when Miss Washington says her about her favorite?
Which one?
The lady that always did her ink and then she never got it. Haley. Haley.
Smart people.
Let's try.
Do those 8, please. Remember, guys, as you're working through these things, your best bet is to always, always, always label what you're trying to work with. When you label what you're trying to work with, you're going to be better off solving everything, because then you've got all your different ways of doing it excuse me, in front of you. Bless you.
Thank you.
Okay?
And someone stops me.
No, like, you're about to sneeze and then you just don't sneeze. I don't want.
Never had.
You never had that yet? It's an all thing. You've had that thing.
What?
Like when you're about to sneeze and then you just don't end up sneezing.
And it's like tingly.
Yeah.
And you feel it, it's like
You know what I did the other day? I choked on water.
Ladies and gentlemen, you have some time right now. Let's go.
We had the whole flex pass.
Ladies and gentlemen, there's no excuse for you not to be working on your stuff that's up on the board.
Did you send it to